this cell will be replicated n number of times based on my architecture, and it will simplify the things. So these are ResNet network. I have implemented different networks. I have chosen, as I already said, I have gone only for the transfer learning models, realizing onto the hardware, not on the software simulation. These entire things in the hardware simulations. So of that internal details is as it is already previously I have shown the same thing. So this is my hardware scenarios, wherein like you can see like a step by step, like from the top, whatever the code that we are trying to write, like maybe like Python or something, R programming language, or no, I don't know, like I can know about only C or C++, whatever the programming language. The top level there are some deployment environment variables are there. You can use whatever the networks, like import TensorFlow Hub. It will automatically import everything. As you are using the Python, the same thing can be done in the hardware because there are some predefined environment variables are there. So I can import everything. So Vitis is the library. Vitis is the library. So you can see. Here you can see that Vitis, video analysis and SDK, software development kit. So a part of the thing I can write using a VLSI, and a part of the thing I can write using like the maybe like you can, if you are confident on Python language, you can write using Python. If you are confident on C language, you can write using C language. No, I don't know anything. I am confident on MATLAB. You can write a part of the thing in MATLAB and a part of the thing in like VLSI. We can try to merge both the things that make the life simple. Otherwise, if I am going to develop everything from the scratch, none of the industry has preferred that. You need to pick up something from somewhere else and you can use it. So, in the same way, I am using software development kit. What is around 1 lakh? I have taken from the NVIDIA the board. So, for testing purpose only I have taken. So, but we need to develop. But these libraries we need to buy. These libraries, because these libraries are given by the Xilinx. Right now, for example, if you are trying to buy the latest boards, right now I think Zinc, most of the colleges are familiar. After Zinc, there are so many boards are there, like ping boards. If you are going to buy the ping boards, means no need to write the code in Verilog or VHDL. You can write the code in Python. Automatically, the code will be converted to the Verilog, and it will give you the best results. PYMQ, ping, Python. PY stands for Python. So in the same way, Zinc boards also. There you can dump your software, sir.
Ping is a software.
No, that is a hardware. The hardware boards. Where the software is same like as I was saying. If you know Python, you can write the code in Python. I don't know.
Give it to that hardware.
It will automatically convert it to the hardware and it will give the results. This ping board cost is around 27,000 rupees. This ping board. Now, what I have done is like a Zinc board plus some GPUs I have added. So it is Zinc doesn't support. Verilog or C language. As I mentioned, like SDK is there. In SDK, if you are familiar with the C language, you can write the entire architecture using C language, and you can dump it. So any one of the language is sufficient. But if you are going for a ping means, you can dump your Python code into that. Whatever code you are studying, entire code you can dump. But for libraries, there is some different model is there. Like how you need to dump your libraries. Like Python, you are using NumPy libraries, or SciPy libraries, or else for deep learning, some different libraries are there, plotting, whatever the things you are doing. So those libraries, there is some different procedure to convert your Python into hardware equivalent. Because we are not going to use all the, in Matplotlib, if you are going to choose, there are n number of libraries are there, n number of functions are there. We don't want the n number of functions, we want only 2 to 3 functions. Only those 2 to 3 functions should be converted into the hardware to improve the performance. That's what my question is.
Excuse me, is it open source?
Which one?
It is verified software.
No, like it is not open source because they are not till now released. Like only payment. Like college we are seeing only up to Xilinx only we are seeing, and Vivado basic versions. Vivado basic version they doesn't support these hardware and
Some
services.
software they are giving as open source for
No,
education purpose, no? Like that any other software is available.
I don't think so.
This MATLAB has got support for
that we are having in Zinc also we are having. Zinc also we can write your part of the code in MATLAB and you can interface. If you are familiar with Sysgen is a software where you can write your codes in MATLAB like Simulink. The same way you are doing for Simulink, but in the same system, MATLAB and Xilinx should be installed. If you are going to use a Sysgen means it will automatically convert your Simulink blocks to your Verilog equivalent code. So that makes the system smooth. So as I mentioned, like here you can see that BITIS HLS is there. BITIS HLS. HLS stands for High Level Synthesis. Means you can write your code in C language or Python language. High level program, it will convert to the hardware equivalent, just like we are doing our C language program to hardware equivalent. So after that, you can see that after BITIS HLS, there is a RTL kernel wizard and AI compiler engine. So these two are not available in the older things, these two are available in new things like AI kernel engine compiler. What it is trying to do is, it will take the help of your AI and it will try to simulate everything in whatever the way that you are trying to do. So, like entire AI, it comes into a part and parcel of your FPGA board or something else. So after that, I said, like Xilinx runtime library. So all the libraries will be imported here. In the last Xilinx runtime library. After that, it is like a British target platform. What is the platform that I am using? What is the board that I am targeting for? So we need to choose a custom board and everything will be done in the board. So here I have displayed like what are the different boards are available, some G boards. Most of the colors, even like normal colors also. Now G boards comes with the hand. I think most of the colors we are having G boards. It costs around 40K. So G boards and this is the boards like Alveo cards. These are the things where I am interested because Alveo cards by default internally, if you buy Alveo cards means internally it is having the A engine. If you are going for some other cards, you need to buy the A engine. But if you are going for an Alveo cards, internally it will be having the A engine. So if you are going to choose run your algorithm, it will invoke the A engine and it will make your system to run speed. So this is the brief like how we have developed the models like from hardware model to like developing the things until results. So this is the DPU architecture what we have chosen. Like there you can see that PE is the term is a processor engine. Like the basic neural network architecture. The basic neural network. Previously I have shown on same basic neural network. The basic neural network architecture will be in the PE engine. Now most of the people are doing research on the PE engine. Like because we are the faculty, we are aware like performing a FIR filter for a normal thing. We can assume that performing an FIR filter, like let us take a 5x5 like a input like X should be like a size of 10 and H is of order of 3. Assume the amount of computation and similarly assume for the neural network. Neural network, if the input size is like 220 by 20 also, the number of input layers are 40K and each and every stage we are performing some kernel, nothing but convolution, we are performing the operation. If each and every layer is having some convolution operation, assume how much amount of resources or else how much amount of time it's going to take. That's why it's a very huge amount of time. That's why nowadays most of the researchers, if you look at the latest research papers, most of the people are looking at the systolic array architectures, wherein the performance of the system keep on increasing. We are not going for a normal array design of FIR filters. Nowadays most of the people are going for systolic array FIR filter, where the performance of the screen keep on increasing. That's why I use like PE, basic systolic array architecture I use. If I am going to improve the systolic array architecture, definitely I am going to do antibiotic because it is enough for high only. It may improve the performance. So after memory cooling, as I said that like if you are going for realizing the deep learning algorithms onto my system, the first and foremost problem is my memory. and I will run out of the memory as the time keeps on increasing. So what here it is going to happen to is it will take some part of your RAM and it will try to do the things and it will clean up for a very little iteration. In that way, it is going to reduce, like it is going to overcome the memory limitations of your systems. So high speed directly, RAM and this here I have implemented. So you need to be aware of different things like the floating point of view. Because everything is a floating point number, so not integer numbers. But if someone is aware of VLSI, then they can know that the floating point number is tough to implement in VLSI. So I need to go for a compromise scenario. So all the compromise scenarios are done, and after that I have completed the GIMP codes with the help of already I said the class. Like so these are things you wanted to address. So you can see the coding also. I have used a basic Python coding. I have not used any Verilog or something else, a different unknown code. Whatever things you have studied for the last 5 days, the same coding I am using. And here I am going to look at how much amount of time it is going to take. I am bothered about the time and how fast it is going to fetch and it is going to display. So this is code support. I have taken GIMP code along with some GPU website. So here you can see like I have numbered with different models. Different models. There you can see like what is the like Coral boards, HTTP, Raspberry boards, and so here I have taken the help of one of my students also. He has taken he has done on Raspberry boards and we have done on G boards. And we have compared the different algorithms and we have displayed it. And this is the thing like how much amount of first one is the amount of accuracy we are going to get, like 99% accuracy. Remember, like for training itself, it is taken around like 12 hours of time, only for training. I have said already 6.4 GB is my data size. For training itself, it has taken around like 12 hours of time. After that, whatever the images we have taken and we have given as an input from the web itself, not the trained images. We are trying to do the different images. It is going to display within a moment. Almost like a maximum of it is taking like 22 seconds. The burst image has taken 22 seconds. So that's it. And
Good terminology you have introduced us.
But we need to be aware like anyway we are trying to realize everything, but at the end it needs to sit on some hardware. So most of the people right now we are looking for Raspberry boards or something else wherein we are dumping, because right we are not a core persons to dump into the Raspberry boards. But it is ECE by default we should sit into the hardware. So whatever hardware we are looking for is like FPGA is the only solution. Huh? And nowadays software also comes in handy, like you can do whatever the programming wants. Like even ARM programming, if someone is aware of ARM programming language also, it is given like ARM engines are there within the FPGAs. ARM engines, Python you can use, C language you can use, C++. Every flavor is being touchable by the hardware. So they are trying to break the like barriers. Like previously only whoever knows Verilog or something else they can build the things. Now there is no barriers. Being familiar with only Xilinx Simulink, MATLAB Simulink, can build. I am there to help. I don't know about Simulink, I know only Python. You can write, I am there to help. SDK should be. System should be. MATLAB, systems was, I think in your college, every batch. Because they will give like free of cost. It will start from long back notes. But most of the people don't use systems. That's why I'm saying we will not use systems. No, system comes into the part and parcel of Xilinx. So Xilinx and MATLAB should be work on the same system. Then the MATLAB you need to encode the units like already Xilinx has been used. And whenever you open the simulink, like there on the top right, you need to place like Xilinx system should be there. Some icon. If you are going to place that icon means the entire code only whatever the functions which are simulatable by Virula, those functions only you need to drag and drop. Otherwise you cannot drag. So like that, or else you know, I don't want to, like I want to write some functions on my own and I want to dump. You can write the function, you can dump. So you can call back the functions also. MATLAB is like a learning language. So MATLAB will not be able to like imports we use only for external hardware interface because my belief is like hardware we give the better performance. Not think about this something like that. What I have done is like external interfaces, the SDK interface I will use. Otherwise, the SDK means software development where you can write C language also. So there I have written an interface. So I have used different language for different purposes so that it will make the interface. So like a class, okay, this part is mentioned for this purpose, this part is mentioned for this purpose. So whichever is having advantage, that part I am choosing. Maybe some other way also, maybe.
Any queries? Audience? All the faculty and students are benefited from the views of subject and the lecture. Thank you, sir. Once again, we thank you very much and look forward for your presentation in future as well. Thank you, sir. Thank you for your valuable sessions, guidelines, experience and expertise in image processing, implementation of deep learning algorithms for image processing applications. Thank you, sir.